Let's discuss a question on theory of machines, vibration. What is given? Let's see what is given first. The period of oscillation of damped linear oscillation for 1 kg mass is given. So you have a spring, basically a spring mass damper. Okay. Basically we study spring only a single degree of freedom spring mass damper in our BTech level. So don't worry about the other degrees of freedom. The period of oscillation for this damped linear oscillation where mass is 1 kg, okay, and the stiffness is also given as 800 Newton per meter, and the time period of the time period of this damped oscillation is 0.3 seconds. So we are asked to calculate the damping coefficient. Now the damping time period is given as 2 pi by the frequency of damping. So this is the normal thing, right? This is the angular speed. I mean, in circular sense, it's angular speed of damping. So angular speed of its oscillation, and so it's in one second how many times it can oscillate. That if you take the reciprocal, it becomes basically in how much time it takes for one circular revolution. 2 pi is to convert into linear sense, so 2 pi by omega. Now this 2 pi basically the time period is given as 0.3, so let's write this as 0.3, and from this I can find out the frequency of oscillation, damped oscillation. 2 pi by 0.3, it is 20.943 radians per second. Okay, so now this omega d, if you look at the math of this undamped oscillation, this omega d is given as 1 minus the damping ratio whole square into omega n. So this omega d is basically this formula, and this is 20.943. so this omega n is basically given as is the natural frequency, and for a spring mass damper it's root k by m. So 20.943. Now in this we know everything. K is given as 800, mass is 1 kg. So from this I can find out the damping ratio chi, because this equation will give you damping ratio chi. So this comes out to be 0.672. So we need the damping coefficient, and the damping coefficient is defined in terms of damping ratio as 2 chi m omega n. So these set of equations are all coming from the undamped math. If you look at the math of mathematics on the derivation of undamped oscillations, this will be clear. So damping ratio is 0.672, mass is 1, and omega n is 800 by 1, that is root k by m. So this value, if you calculate, it comes out 38 Newton second per meter. So the answer for this is B. The option for this is B, 38 Newton second per meter. Thank you.